What role does the pulse program play in the SSNR technique, and how can it be adjusted based on the information obtained to selectively suppress unwanted data while retaining the desired information? How does this ability to fine-tune the pulse program contribute to the specificity and efficiency of SSNR experiments? What specific observations can be made from Figure 2.6 regarding the behavior of 23 now resonance at lower temperatures, and how does it broaden under second-order quadrupole interactions and dipole interactions? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the line shape of the cubic phase Na3PS4 change at 393 K, and what does this indicate about the mobility of sodium ions in the material at this temperature? Why is the central gravity shift toward higher ppm 10 to 6 value significant, and what does it suggest about the relationship between sodium ion mobility and quadrupole interactions at elevated temperatures? What does the NMR spectrum of cubic structure Na3PS4 reveal about its properties at different temperatures? How do the characteristics of the NMR spectrum change as the temperature of Na3PS4 is varied? What can the NMR spectrum tell us about the structural behavior of Na3PS4 in the cubic phase at different temperatures? How does the temperature influence the interaction between sodium ions and the surrounding lattice in Na3PS4, and what impact does this have on the NMR signal? In particular, how does the behavior of the 23 now resonance shift when the temperature is altered? What specific changes in the NMR spectrum indicate shifts in the dynamics of the material at varying temperatures? How does the broadening of the resonance lines under second-order quadrupole interactions and dipole interactions reflect the nature of sodium ion mobility at lower temperatures? At higher temperatures, such as 393 K, what happens to the line shape of the cubic phase Na3PS4, and why does it become isotropic? What does the shift in the central gravity of the spectrum toward higher ppm 10 to 6 values suggest about the sodium ion's behavior in the material at elevated temperatures? How does the increased mobility of sodium ions at higher temperatures help to balance out quadrupole interactions in the NMR spectrum? What role do temperature-dependent changes in the NMR spectrum play in understanding the ionic conductivity and dynamics within Na3PS4? How can analyzing the NMR spectrum at different temperatures give insight into the thermal stability and structural transformations of Na3PS4? How do these NMR observations contribute to our understanding of the material's potential applications, particularly in energy storage or other fields requiring ion mobility at different temperatures? What is the thermogravimetric analysis (TGA) technique, and how does it work in terms of measuring the relationship between the mass of a sample and temperature changes?